Hello everyone. So today we will be solving the fifth problem of the contest, the CodeForces round 1103 div 3 problem. The problem is a very great problem. You will understand many things. We will start from the scratch. We will have a brute force and then we will try to optimize it as we go on the code. Right? So let's read the problem statement first. So the problem says that Arsene decided to make his friends Dabir and Igor happy. For this, he decided to give each of them an array of numbers of same length. An array B is called good if its element can be rearranged so that for all I greater than 1, the condition bi minus 1 is equal to 1 holds. Okay, Arsene wants Tabir and Eager to be able to play with these arrays. For this, the following conditions must be satisfied. What are the conditions? The conditions are that each of the given array is good. That is, if you write one array, and the second condition is if you write one array after another. In other words, if you concatenate them, the resulting array is also good. So Arsene already has an array of length n. He plans to cut both arrays from A, that is to choose two non-overlapping subsegments of the same length. Help Arsene determine the maximum possible length of the resulting arrays. All right, so a great problem, right? Let's try to understand what the problem says. The problem says that a of I minus a of I minus 1 should be equal to 1, right? That is, a of I should be equal to 1 plus a of I minus 1, right? Now the problem is interesting because you are given an array, right? You have to pick any subarray from, let's say you choose this subarray, let's call this subarray 1, right? And you can choose another subarray, let's call this subarray 2, right? So the condition is for the subarray 1, right? Subarray 1 should hold this condition that every element in that subarray, you can rearrange the array, right? You can rearrange the array, and after rearranging the array, right, the condition that current element should be equal to previous plus 1 should hold, right? Now what does this mean? Let's say if my subarray has 4 elements, then the subarray should look something like, let's start with a value 6, right? So if you had a 6, then the next element is bound to be 7, the next element is bound to be 8, and next element is bound to be 9. So this is a valid subarray, right? You can call this subarray as a valid subarray, right? And the second subarray, that let's say there is a second subarray and I am planning that when we concatenate them, this condition will still hold, right? That is, let's say the next subarray you choose, the value should start from 10, then 11, then 12, then 13, right? And if you concatenate them, right, what you will get ultimately, that is 6, 7, 8, 9, 10, 11, 12, 13, right? So this is what the problem states, right? You need to return the maximum subarray length that you can have, right? Maximum subarray length, right? All right, we will look at a few test cases. Before that, what is the time complexity of the problem? N is given as 6000, right? So the problem expects you to write a solution which works in big O of n square, right? All right, let's try to think how can we write a solution for this. Let's look at the few test cases. 2143 is the test case I think I should look at. 2143. So a valid permutation would be to pick up this subarray, right? If you pick this subarray and the next subarray is this one, right? So let me write with the red color. If you sort the elements, it becomes 1 comma 2, and the second array is 3 comma 4, and if you look, the condition holds perfectly in this subarray s1, in this subarray s2, and the final subarray s3, which is concatenating them, which is 1 2 3 4, right? So the maximum length that you can get from this array is length is equal to 2, right? And let's look at one more test case just so that we can be sure of it. So if you look at this subarray, right, let me copy this quickly, right? Yes, I hope it is copied. Let me paste it. Really sorry for this. Yeah. It's not copied, I guess. Give me a second or so. Really sorry for that. And meanwhile, while I'm copying, if like if you are interested in these kind of content, like I do post contest discussions of the problems, so you can definitely subscribe to the channel. It motivates a lot, right? It makes us feel happy to make more content like this. Really sorry for wasting a minute. So let's look at the this case, right? Now, in this case, if you look closely now, if we break this subarray, right, the subarray, let's call this S1 and this subarray as S2, right? So, if you rearrange this subarray, it becomes 1, 2, 3, 4. And I think I don't need to repeat, this is a valid subarray. And 5, 6, 7, 8, this is also a valid subarray S2. And when you concatenate them, which becomes S3, all the elements 1, 2, 3, 4, and the starting element 5, 6, 7, 8 is also a valid one, right? So till now, I hope I'm able to make you understand what the problem statement actually asks from you, right? Now, if you think closely, if we can generate all the possible subarrays, it will take big O of n square. I hope everybody knows about how to generate all the possible permutations. I goes from 0 to n, right? I plus plus, and j goes for from 0 to n, right? And this is the possibility of creating all possible subarrays, right? If you create all possible subarrays, then you need to check validity of each subarray, check validity, right? And even after you have checked the validity of the subarray, then you need to check that is there any more possible subarray which has the same length, right? Means let's say you had a length of 4, right? Then you need to find a subarray of length 4 in the future subarrays, right? Not in the future subarray. Let's say you found out this one, right? Now you have to check, run another for loop which generates another subarray, and you need to check for this, that is this subarray valid or not. So even if you look at these types, right, generating all subarrays will take big O of n square, and checking validity will take big O of n. This only, let alone makes big O of n cube. So you can't run another for loop or anything else to generate another subarray, right? I hope I'm making sense till now, right? So we need to think of something better, right? Here comes my first claim, which will help you optimize the problem. Claim one is, see, you can't run away from generating the possible subarrays. So one thing is for sure, that you need to generate all possible subarrays, right? Generate all possible subarrays. Okay, you will say, all right, this will alone take big of n square time, right? So now whatever code we write, that should be either in big O of log n or big O of 1. We can't afford anything greater than these two, right? I am saying let that be, right? Now what my second claim is, my claim 2 is very simple. My claim is, let's say I have an array, right? Let's call the array of length be len, right? In this, I have a few things to discuss. Let's say this value had, let's say this array has a maxi, and let's say this array has a mini, right? We can calculate while we are traversing on the array, the subarray, right? As we go further, we can update our maxi and mini, right? That won't take extra time, right? What I'm trying to say at this point is, let's say if you have an array of length len, subarray of length len, how many distinct element will you have? How many distinct element will you have? Think of it. If I am saying this element can be x, then this is supposed to be x plus 1, this is supposed to be x plus 2, this is supposed to be x plus 3, and this is supposed to be x plus 4, right? How many distinct elements are here? Every element is distinct, right? So if I have an subarray of length len, every element should be distinct. That means my first claim is that number of distinct elements should be equal to length. Yes or no? I hope this is very clear to you. The claim 2 is clear to you, right? And why so? I have given a proof to you as well, right? Go every time with the proof, right? Without proof, CP is nothing, right? Let's go with claim 3, and a beautiful claim as well, right? My claim 3 is, let's say what the maxi and mini we were talking about, right? So you will update maxi and mini, right? And mini. Now let me give you a beautiful maths, or we can say a expression that will help you a lot. And the expression is something like this, that maxi minus mini should be equal to length minus 1. You will say, hey, now this is very unobvious, like how can you say that, right? Let me prove it, right? Whenever I say I can prove something, means not I can prove something, whenever I say that you should try to prove something, do it, because when you try to prove something now, that concept becomes a solidifier for you, right? Means you can use that concept in future, you will have a clear picture of the problem statements as well. So try like focusing on more on the proofs, right, and understanding how that solution works in general, right? Sorry for the again. So what I'm trying to say is maxi minus mini should be equal to length. Now you will say, hey, how is that so? As we saw, x plus 1, x plus 2, dot dot dot, x plus, let's say 5 is the maximum element in my subarray, right? This condition should hold, right? X plus 3 and x plus 4 as well, right? And the length is 1, 2, 3, 4, 5, 6, right? Now if you look, what is the maximum in this subarray? It is definitely x plus 5. And what is the minimum in this subarray? That is definitely x. So what I'm saying, x plus 5 minus x should be equal to length. What is length? Length minus 1. So this becomes 5, and here the length is 6. So 5 is equal to 6 minus 1, that is 5. Yes, this condition is proved, right? We can prove this as well. So every subarray which is valid, these two conditions should hold definitely. Yes or no? Tell me that, right? If yes, do give a like, drop a comment, and subscribe as well. Will help me a lot, right? So till now, I hope you understood what are the two claims. Let me repeat those two claims. The first claim is the number of distinct elements should be equal to length, right? And the second claim is the maxi minus mini should be equal to length, and we have proved it as well. Why is that condition so? Now let's come to the final nail in the coffin, right? So what we will do is, while we are traversing on the subarrays, right, for every subarray, for every subarray, you will check, you will check if that subarray is valid or not, right? That subarray is valid or not, right? How much time will it take to check if the subarray is valid or not? It is taking big of 1, right? Because we are calculating maxi, we are calculating mini, and we are calculating number of distinct elements. How can you calculate distinct number of distinct elements? It is very simple. You can use either a set, or you can use a vector as well, right? Vector of, like how we do in int visited, seen, anything you can check, take and update the values of those as well, right? So till now you will say, okay, we can find a subarray of length, let's say we can find a subarray of length and the maxi value it had, right? Till now this point is clear to you. But hey beast, even if you do so, how will you calculate the another subarray of length, right? Because for that we saw that initially we had, again we need to run a for a subarray, but now we can't afford it because we are optimizing it. How will you do that, right? I am saying, hey, listen to me. Let's say I have a subarray which goes something like this, which has a length 4, right? And it goes by 1, 2, 3, 4, right? It is a subarray, not a, it is a subarray, right? Let's call it S1, right? You tell me one thing. If I had another subarray, right? Let's call it S2. What should be the starting value of that subarray? The starting value of that subarray is 5. I hope you guessed it from your end. The next element should be 6, 7, and it should end at 8, right? So if somehow I create any type of data structure that stores my maximum of a subarray, right, and the length of the subarray, then can I figure it out another subarray of length len, and the maxi should be something like, let's call it x as of now, right? That means, let's say, let me have a quick brainstorm with you. For this example, if I have a 4, right? You tell me one thing. If I have a length of 4 and I have a maxi of 4 in the subarray 1, What is the supposed to be the next maxi? Means the subarray 2, what should be the maximum value for that subarray if I had a length of 4? It is bound to be 8, yes or no? Because 4 plus 4, the length is 4. If you are uncomfortable with 4, let's start with 3, right? So that you can be more clear. So let's take 3, 4, 5, 6, right? Tell me one thing, if I had a 3, what if the max is 6, what is supposed to be the maximum element of the subarray, which should be the consecutive of this, right? The subsequent, when we are concatenating these two subarrays, right? That was the problem statement, right? So the next subarray's maximum is bound to be 6 plus 4, yes or no? That means the subarray should look something like this. Now you have a clear picture that okay, if somehow I calculate this value, which is my maximum in subarray 1, right, which is 6, and the length, which is 4, then I can know the maximum of the subarray 2, right? And you tell me one thing, if I have a subarray 2, if I somehow map these values, what do I map? I say map of dash comma dash. What does this dash means? This map means maxi and this means length. So if I have a map which stores the maximum value, that is 6 for this subarray, so this will have map of 6 and length of 4, right? This plus plus, right? Now what does this desire to have? Beyond, let's brainstorm. What does this desire to have? This desires to have a length of 4, means thus another subarray which is h2 must have a length of 4, right? And the maximum value in that subarray is bound to be 6 plus 4, which is 10. That means if my map had a value called 10 comma 4, then I can say that these two arrays can be concatenated and then still that value will be valid, yes or no? Was it a wow moment for you or not? Tell me, write in the comments. It does give reach to the video as well and motivates me as well. Tell me that this solution is wow or not, that if you somehow map this value as plus plus and that has a desired value of something like this, if you had this value in your map, right, then you can say, hey, wow, I got a subarray of length 4 which is valid, yes or no? And we can have a maxi or answer which updates as we go, as we check for all the possible subarrays, right? So what we will do is, we will, as I told you, we will find number of distinct elements. We will check if it is valid or not by maxi minus mini should be equal to length minus 1, right? And then we will map them, right? Map of maxi comma length, right? If you have any doubt, do drop in the comments, right? After this, what we can do, we can simply traverse on all the values of maxi and length. See, maxi can have a value till 6000 only, because it is given the problem that AI has a value a1, a2, an, the value can be less than greater than equal to 6000, right? I think I can't, yeah, this is the place which I'm talking about. So the value can't be greater than 6000, right? So if the value can't be greater than 6000, I can say for int I equal to 1, I less than equal to n, I plus plus, and the length can be equal to, we can name as maxi, and the length is from 1 to length is equal to n, right? So we will have all the value of map. So map of maxi comma length, we can write something like this. If this value exists, right, so we will say, let's say map of some, look, it might look something like maxi is 6, length is 4, right? So if we had this value, we will say, hey, my desired value is something like map of 6 plus 4, 10 comma 4, yes or no? If you have this value, then update the maxi, update the length, length can be max of length till, I hope this part is very obvious that you need to find the maximum length and how can you do so, right? So I hope the problem statement was clear to you. If you look at the time constraints of the solution, it is big of n square because we are running on for loop, two for loops or all the subarrays, and we are doing nothing else, right? So we have optimized this code to big of n square. That is a great solution if you have focused till now, right? Now let's quickly look at the code, right? So what I'm trying to do is, I have created a map, right, which is the map I was talking about, right? Then we are running a for loop I equal to 0 to n. We are having a maxi, we are having a scene. Scene is nothing but if that element has been visited already or not, right? We have a distinct, we have a mini, right? So what we do is we start from for int j equal to I to j less than n, j plus plus. We are updating the maxi, we are updating the mini, and we are updating the length as well, right? So if the value is not seen earlier, right, then we update the scene, right? That the scene, this value has been seen now, and the if this value hasn't been seen earlier, that means this is a distinct element, right? So we do a distinct plus plus, right? And then we check the conditions for what we had earlier, right? That is distinct is equal to length, number of distinct elements should be equal to length, and the maxi minus mini should be equal to length minus 1. If that is so, we will say map of maxi comma length is true, right? That this value exists in my subarray somehow, right? Then what we do from maxi equal to 1 to n, so that we can traverse on all values of maxi comma length, right? While doing so, we will just simply check if that value of maxi, map of maxi comma length exists, then we have a desired maxi. And what is that desired maxi? That desired maxi is nothing but maxi plus length, right? Now what I'm saying is, if my desired maxi is less than equal to n, and map of desired maxi comma length is also there in my subarray, then that means that is a valid subarray we have got. Yes or no? Was the proof helpful for you? Right? The code is over, and I hope the solution was helpful to you. If yes, please do drop a like. Please do subscribe as well. You can see I have been trying from a long time. Not from a long time, but I have been uploading videos from regularly as of now. But I don't get that much support. I'm not like, I don't want sympathy for you from you. I want is that you can support me as much as you can by just subscribing. It's free. So do so. Thanks for watching. And if you have any doubts, do drop in the comments. I will help you then and there. Right? Will try my best to help you out. And thanks for watching. That's it for the video.